Yeah, good morning, students. In this particular CDT, we would like to discuss about the array implementation of the Q data structure. So, I would like to share my screen. Hope my screen is visible to you. Fine. So, thank you. So, this is week 6, lecture 3, operations of Q data structure implementation using arrays. So, summary of this session is that previous session is that in the previous CDT, we had discussed about this postfix expression evaluation. We discussed that. So in this postfix expression evaluation, what we did here is that we have created an empty stack and we started scanning the expression from left to right. So if the element scanned is an operand, we are pushing that into the stack. If the scanned element is an operator, we are popping the topmost two operands from the stack and we are applying that operator in this particular order and pushing back that result into the stack. So once we reach to the end of the expression scanning from left to right, then the value that is available in the stack is your final answer for this evaluation of this stack, evaluation of this postfix expression. Fine. So that what we discussed by taking one example in the previous CDT. Now the today's lecture objective is that this session will develop students knowledge on the Q data structure. How do we implement these Q operations using these arrays? The lecture outcome is that after completion of the session, students will be able to develop the code and implement the Q data structure using arrays. So what is a queue basically? So in a queue, we have defining two important operations, insert and delete operation. Insert is called it as NQ operation, delete is called it as a Q operation, and these operations can happen at both ends of the array. So from one end of the array, you are performing the insertion NQ operation. At the other end of the array, you are performing the DQ operation. From front, from where you are performing this, from which end you are performing this delete operation, that is call it as a front, and from where you are performing the insert operation, that is that particular end is call it as a rear end. Okay, front end and rear end. So deletion will be done from front end, insertion will be done from rear end of the array. Fine. So Q always follows a FIFO, first in first out order. That is the element which is entered first into this array is the element which will be dequeued or removed first from this array. So that is the reason Q data structure is called it as a first in first out data structure. Whereas a stack is called it as a last in first out data structure, LIFO data structure. So which is latestly we have inserted or pushed, that is the first to be popped from the stack, that is removed from the stack. Fine. So insert and delete operations in the stack is called it as a push and pop operations that we already discussed in the previous CDTs. Fine. So now these Q operations what we have seen NQ. So when we require to add an element into the queue, we perform the NQ operation. So initially rear equal to front is equal to -1 we will put. So all these array elements are empty. A of 0, A of 1, A of 2, A of 3, A of 4. So we are assuming that an array of size 5 and initially there are no elements in the queue. Now we are inserting rear equal to -1 and front is equal to -1. So NQ of 5. So that means we want to insert element 5. Then what will happen here? So front and rear will be incremented here and we kept the front and rear here itself at 0th location and we are inserting 5. So again NQ of 7. Then we want to insert 7 here. So front will be at 0th location. Now rear will be at first location. NQ of 9. So we are inserting 9 element, not 11 here. This is 9 element. So we are inserting that. Now rear is at this A of 2 location and front is at A of 0 location. Suppose we want to NQ of 15. So now we are inserting 15 Fine. So now rear is equal to here, A of 3 location, rear is equal to third location, and 15 will be inserted here. So like this we will do that when you are enqueuing of again, suppose 20 you want to insert that. So we will insert here, rear is here, and 20 will be inserted here. So when we want to insert one more element, then the queue is said to be full. So we cannot able to insert a queue. Fine. So this is what we are to do is basically when we are performing that. And similarly, DQ operation, when we require to delete or remove an element from the queue, we perform DQ operation. DQ operation is synonymous of deletion or removal in the data structure. So always DQ means first 5 will be removed, front element will be removed. Now we will kept this 0th location as empty. Next DQ means 7 will be removed here because this is the front here. Next, if you call DQ operation, 11 will be removed because front is at this. Now front is also coming here. Rear and front are now at this same location. Fine. So again, if you call DQ, 15 will be removed. Fine. So now front goes here. Okay. So that means front and rear. Rear will be here, front is here. So now there are no elements. This becomes empty, and as well as this becomes empty. So this is also empty here. So then we are going to get it as a queue empty. So there are no more elements to delete. Fine. This is what we are calling it as a DQ operation. So what are the applications and uses of the queues? So the queues are heavily used in almost all applications of the operating system, like scheduling of the processes, moving the processes in and out of the process scheduler, first come first serve, AJF, etc. These are the different types of scheduling algorithms where we are making use of these queues. Asynchronously, that is when data resources may be the same but not received at the same time. For asynchronous transmission also, queues are used. Anything that has to do with process and schedule in the system or code, we will make use of the queues. Similarly, in the printers also, we are making use of a queues whenever we are given multiple jobs for printing. So those multiple jobs will be put into the printer queue so that one job is completed, then next job will be taken by the printer to get print of that particular job. Like that, printer will make use of print spooler, we can call it as, which is also a queue data structure. So this is the program. So we have NQ operation and then DQ operation. So this is the one function we have here, NQ function. Okay, and we are taking Q is a integer array of size 5. Front is equal to -1, rear is equal to -1. If rear is equal to size -1, Q was full. If front is equal to -1, front is equal to 0, rear plus plus, and Q of rear is equal to data. And DQ operation, if front is equal to -1, Q was empty. Okay, else DQ we are performing here. If front greater than rear also, then front and rear is equal to -1. So once front crosses, when you are deleting that, when front is crossing rear, then you have to bring all this front and rear to the beginning of the array. This is what the display operation to display what are the Q elements currently available in this. Okay. So for I is equal to front, I less than or equal to rear, I plus plus, then you have to print percentage D Q of I value. So this is what the for loop we are using to print these array elements, which from Q data structure. If rear is equal to -1, Q was empty. Fine. So this is a main program where you want to print that menu for displaying of these queue operations. Fine. So similar to the stack operations which we did through menu driven program, similar manner we have to do with menu driven for queue operations also. Here we have NQ, DQ, print the queue or display the queue and then exit. These are the 4 options only. So we have to make you read the preference or read the option, and based on that option you have to write the case labels. Case 1 you have to call the NQ, case 2 you have to call the DQ, case 3 you have to call the display, and case 4 exit. Fine. So now this is what the reflection spot show the queue after performing the following operations. NQ12, NQ22, NQ32. That means now Q will be having after these three operations 12, 22, 32. Front will be at 12 and rear will be at 32. DQ, DQ. That means you are removed now 12, 22. Now front is equal to 32, rear is also at 32. Then NQ 42. So rear now becomes 42 position. Then NDQ, then what is this display? 32. So in the Q presently you have only 42 in the Q we have. Fine. So if you are not able to answer this question, please watch the video from this beginning. Okay. So LOs are revisited here. After completion of the session, students will able to implement the Q operations using arrays. So summary of this today's session is that Q is a data structure where these insertions and deletions are takes place at opposite ends of the array. So where insertion operation is also called it as NQ operation and deletion operation is called it as DQ operation. So insertion will be done from a rear end and deletions will be done from front end. So the two opposite ends we are making a naming convention that front and rear. So Q follows always a FIFO first in first out structure. So that is the first element which is inserted is the first element to be removed from that queue. Fine. So there are a lot of queue applications also we have. So in the printers and operating systems will make use of the queues. In real life also we have queues which we come across in different public places at different public service counters like at cinema theaters or at different booking counters. We will observe this queue data structure. Fine. So this is a lecture level practice problem. Implement the code for queue operations using two stacks. This is another important operation. Fine. So if you want to refer further on this particular queue topic, you can refer this particular textbook as well as other reference material. This is further readings. Right. So thank you one and all.